The objective of this video is to learn how to solve equations using the distributive property. And just as a reminder, the distributive property is when you have A times the quantity B plus C. That's the same as doing A times B plus A times C, that distributive. You may have seen it with arrows like this. All right. And it doesn't matter whether you have a plus or a minus, it still gives you that same AB, AC out here on the side. One example of this is when I have 3 times the quantity x minus 4. That's the same as saying 3x, 3 times x, minus 12, which is 3 times negative 4. You get the negative 12 there. Another example is the reverse property here, where we've got 2x plus 5x. We can take the two x's, pull them outside as 1x outside of a set of parentheses. And then this would become the 2 plus 5 inside of parentheses. This would then simplify to just 7x. And this is also known as combining like terms. When you combine like terms, you add their coefficients. And the reason why you're doing that is because you are using this distributive property. All right. Now, some textbooks might have steps for solving multi-step equations. I really haven't seen them listed like this. I came up with these 5 steps after working with students for years. They don't necessarily need to be done in the order I have them here. But if you're the type of student that looks at an equation and has no idea how to begin solving, it's good to think about these 5 steps and start stepping through from 1 to 5. First step, what I would generally like to do is multiply by the LCM, or lowest common multiple, of the denominator to eliminate fractions. Now, the next step would be to distribute to get rid of parentheses, which is what this particular video is about, is that distribute step. There will be some combining like terms, which, like I said in the last screen, is an extension of the distributive property. But when I say combine like terms here, in the process of solving, I'm talking about on separate sides of the equal sign. On one side, you combine like terms if they exist on the one side. Look at the other side. If they exist on the other side, you combine on the other side, but you never cross the equal sign to combine like terms until step 4. Step 4 is moving the variables to one side, which is kind of like combining like terms. It's just a matter of moving the variables to one side and then combining them. If you do follow these steps, you'll generally be left with a 1 or 2 step equation, which you can solve using the opposite operations and the opposite order of operations. Okay, let's step through some examples of these. Here we have an example where we have one with a set of parentheses. First question I ask myself, is there a fraction in here that I need to eliminate? No, there isn't. Next, are there parentheses? Yes. So this is where we go to step 2, where we would distribute to get rid of the parentheses. Distribute the 2 to both the x and the 4. I get 2x plus 8 equals 16. After doing that, I can see that this is a 2-step equation. I can draw my railroad tracks, if my pen will let me here. All right, and then I need to do the opposite operations in the opposite order of operations. Right now, the 2x, the x is being multiplied by 2 and having 8 added to it. According to the order of operations, you would multiply first and then add. I'm going to do the opposite in the opposite order. I'm going to take care of the adding by subtracting 8 from both sides. And I do have to do it from both sides. That's going to give me 2x, because these cancel. 16 minus 8 is 8. I'm not finished because this x is still not alone. I got to take care of that multiplying here by doing the opposite, which is divide by 2. So I divide both sides by 2, and I get x is equal to 4. Now, I could, if I started off like this, I could have decided to divide this whole side, both sides by 2 first, which would make these two cancels. I can do that because this entire side is being multiplied by 2. There's no other terms being added or subtracted in here. So since the whole side is being multiplied by 2, I divide by 2 and I get rid of it. I end up getting the result of x plus 4 equals 8. Then I would subtract 4 from both sides. That gives me x is equal to 4. Same answer, just two different ways of getting there. Then we would move on to the next problem. The next problem, you'll see, I do have a fraction. So I'll want to get rid of that first by multiplying by the LCM. Well, there's only one denominator, that's the 5, so that is your LCM. When you distribute that, notice how I'm not distributing to the stuff in the parentheses here. That stuff in the parentheses is already being multiplied by this. So when I multiply this fraction by 5, I am essentially multiplying this by the same thing. This whole thing is really just one term. So I only have to multiply the 5 times the 2/5. 5 times 2/5 gives me 2. Still have the x minus 4 because that does not get multiplied by 5. And I have 15 over here. Distributing for step 2, distribute to get rid of parentheses, I get 2x minus 8 equals 15. Now it's a two-step equation. I add 8 to both sides. I get 2x is equal to 23. So I take that, I'm going to move it up here because I'm running out of space there. 2x equals 23. To solve from there, I would need to divide by 2. Since I started with fractions, I cannot end with a decimal. 2 goes into 23 11 times with 1 left over. Here's my answer on that equation. All right, in this example, there is a fraction, and you might be tempted to remove that first because I talked about that being the first step by multiplying through to get rid of fractions. But since it's inside the parentheses, that makes it a little difficult. Because when you multiply this whole equation, you'll be multiplying the 3 and the 8, but not what's inside the parentheses. So it wouldn't get rid of it right away. I would distribute first. Do the 3 times the 2 items there. You get 3x plus 3 halves is equal to 8. All right, now it's just a two-step equation to solve, but we may want to get rid of the fraction, so we're going to do a multiply by 2 to get rid of the fraction. 2 times all 3 pieces here, all 3 terms. 2 times 3x, it gives me 6x. And then the 2 times the 3 halves will give me a 3. 2 times the 8 is going to give me a 16. All right, now at this point, it is truly just a two-step equation. I subtract 3 from both sides. I get a 6x is equal to 13. And then I would divide to get rid of the multiply by 6, which is going to give me x is equal to. Now, since I did start with fractions in the problem, my answer should end with fractions. So I don't want to make this a decimal. So I'm going to do the 13 over 6 make that into a mixed number. 13 goes into 6 goes into 13 twice with 1 left over. That 6 goes into 13 twice with 1 left over, which is why we get x is equal to 2 1/6. Okay, this problem has two sets of parentheses, so we want to make sure that we actually do the distributive property here. You can't do the divide by 2 or the divide by 3 to get rid of those coefficients there, because if I divide by 2, this side becomes 3/2 in front. If I divide by 3, this side becomes 2/3 in front. We're creating fractions which we'd rather not do. So we are going to distribute both of these to eliminate the parentheses. That gives me 2x plus 8 equals, and 3 times negative 2 is negative 6, and 3 times x is 3x. All right, now, next step, we checked there's no fractions. We did the parentheses. The next step is to combine like terms. 2x and 8 are not like terms. Negative 6 and 3x are not like terms, so we can't combine any here. We can't combine any here. So the next step after that is to move the variables to one side of the equation. I have 2x and 3x. I generally like to move the smaller coefficient over towards the larger one. That way I tend to work with positives. So I'm going to subtract 2x, because 2x minus 2x will become a 0, which will leave this side 8. Whatever you do to one side, same thing to the other. So I'm going to subtract 2x from here, which is going to give me negative 6 plus 1x, which is just x. Then it's just a one-step equation to solve from here. Take care of the negative 6 by adding 6. You get 14 is equal to x. And that's your final answer on that one. Okay, this is a word problem involving a multi-step equation here with some rational numbers in it. Mr. Central's family spends 12% of their annual budget on vacations. They expect to increase their total budget by $1,200 more this year. Increase is a keyword for addition. They plan on spending $6,720 on vacations this year. What was their total budget last year? That last sentence is a big key here. It's telling us that this is our unknown. So x, our unknown variable, is last year's total budget. Now, we don't know anything about last year's total budget other than that they did spend 12% of it on vacations. They're spending 12% of it on vacations this year. This year we know it's $1,200 more than this, and that 12% of it is going to be this. So we're talking about 12% of x plus the 1,200, that's this year's budget, is equal to $6,720. Well, this part here would be done by converting the percent to a decimal and multiplying this by the result, which would look like this. So this is 12% as a decimal. You move the decimal over 1, 2, which gives you 0.12, times last year's budget plus 1,200, which would make it this year's budget, equals this year's vacation budget of $6,720. From there, you would distribute, multiply those together, and you would get this. From there, you would then subtract the 144, and you would end up with this. Oops. This. which you would then divide both sides by 0.12 to get the x alone, and you end up with x is equal to $54,800. So that would be last year's total budget. If they asked the same question but wanted this year's budget, we would have to do the 54,800 plus 1,200, which would give you $56,000 for this year. But they didn't ask that. They asked for last year's. Okay, another example. Let's do this one. We've got a fraction here, and this time it is on the outside of the parentheses, so we can multiply to get rid of it. So we're going to multiply everything by the LCM, which in this case happens to be 5. 5 times 3/5 is going to give you 3. We don't multiply the parentheses by it, so that stays like that. 5 times -3 is -15. And then we have 2 minus x. Again, the parentheses, inside the parentheses stays the same. Then we would distribute. That gives us 3x plus 30 plus 24 is 54 is equal to -30 and positive 15x, because we're doing the -15 times the positive 2 and a -15 times the negative x, which is why we end up with a positive 15 here and a -30 here. From there, we would move the variables to one side. So I would generally move the smaller towards the larger. That gives me 54 is equal to -30 plus 12x. Then I would add 30 to both sides, which gives me 84 and that would be equal to 12x. Divide both sides by 12, and we get 7 is equal to x. And that is our final answer on that one. Okay, this example has a little bit of a twist in that we have this extra term on here, which is one of the reasons why we can't just divide by -2 to get rid of the -2 here. We're going to have to distribute for this one. So we distribute these. We get -2x plus, oh, wait a minute. That is a negative times a positive, so it's going to be -14. Plus the 5x hasn't changed. The 4x plus 17 hasn't changed. Next step, combine like terms. Now you can see we have some like terms on this side. We have a -2x and a positive 5x. So when you combine those, you're going to combine the -2x plus 5x minus the 14. Rearranging the order here using that commutative property. Combine those two, we're going to get those two like terms. We get 3x minus 14 is equal to 4x plus 17. From there, we move the variables to one side, move the smaller towards the larger. I get -14 is equal to x plus 17. Then I would subtract 17 from both sides. I get -31 is equal to x. X is all alone. We've finished the problem. We've solved it, and there is our answer. All right, here are two you-do problems. I'd like to pause the video and give these two a try. Okay, now I'm about to push the answers up here, so if you're holding off, you might want to hit that pause button. Bam! There are your answers there with the work shown. take a moment to look it over. I've got 2 more you-dos on the next screen. All right, here's 2 additional you-dos. You want to give these a try, pause the video. Again, I'm going to put the answers up in a second here, so you may want to pause. Bam! There you go. There are your answers with the work shown for that. I just want to point out here, this was combining these 2 like terms, gave me the +3 here. Hope this was helpful. See you in class.